Hello everyone, very good day to you. My name is Kapil and I welcome you all to this webinar on baseplate design as per Eurocode. Today in this webinar, we will see that how using Midas Design Plus, we can quickly design the base plates and how we can quickly draft the baseplate design. The webinar will be 30 minutes long, and if you have any questions during the presentation and the demonstration, you can write down the questions in the questions window. We will take all the questions at the end of the webinar. So let us start the discussion for today's webinar now. Some of you might be new to Midas Design Plus. Before I go into the details of the baseplate design, I would just like to introduce you about Midas Design Plus. Midas Design Plus is a 2D program for unit member design and drafting. Design Plus supports various codes, including Eurocodes and American codes. Since today's discussion is only meant for Eurocodes, I'll just introduce all the Eurocode design modules in Midas Design Plus. In Midas Design Plus, we have beam design, in which we can perform the rectangular and the T-shaped beam design. Then we have the column design module. In column design module, we can perform the design of rectangular, circular, or any general shaped column, including L-shaped and various other shapes. Design Plus can also perform the design of shear wall, which can be a combined wall, for example, for the lift core wall. Then using the Design Plus, we can perform the design of a pad footing. So it can be an isolated pad footing and it can be a strip footing as well. Along with that, Design Plus is capable of performing design for isolated pile caps. So if you want to design pile cap, you can use Midas Design Plus for easy and quick design. Then in the steel design modules, Midas Design Plus includes steel base plate as well as the bolt connection. We'll discuss the base plate connection in very detail today. And for the bolt connection, just to mention that Design Plus can design end plate connections, fin plate connections, and splicing connections as per Eurocode in the bolt connection module. Now let us see that how effective is baseplate design in Design Plus and what are the various things that we can perform in the baseplate design module. The first thing is that what shapes are available for the design of a base plate. So as you can see here is that basically all the practically used shapes, they can be used for the design of a base plate. You can design the base plate for a box section. So if you have any UC section, you can use the database or you can input the user defined dimensions for the base plate design. And similarly, you can perform the design for an angle section. If you have a column in the shape of an angle and the base plate is used to support that column, then you can design the base plate for that particular column. And then if you have a edge section, then you can use Midas Design Plus for the design of a base plate. We'll see that various other options, how we can customize this base plate and how we can customize this the entire configuration. Then we have the channel section for the design as well. If you want to design a base plate for its channel section, then we can use Midas Design Plus. And along with that, I would like to mention that even the circular pipes, they can be used for the design of a base plate. So here you can see that we have a circular base plate which is supporting a circular pipe, and various stiffeners are added to support the connection, and the bolts are shown here. So the base plate thickness and the rib plates, everything is shown here. We'll discuss all these configuration in quite detail in the coming slides, and we'll see them in the demonstration as well. Now, after the shapes, let's talk about the design actions. Midas Design Plus is capable of designing a base plate for the axial force, bi-axial moment, and bidirection shear force. Most of the programs which are available in the market for the base plate design, they are capable of designing the base plate for axial force and uniaxial moment. So a lot of engineers that I talk to in everyday life, they have to use the spreadsheets for performing the base plate design when there is a biaxial moment and there is a shear force. By developing Design Plus to include all the design actions, we have tried to solve this problem for the engineers, and this will help them in a rapid design of a base plate with a user-defined program, and also generate the reports as well as the drawings very quickly. So if you want to design a base plate for any of these section shapes with any of these design actions, including axial force, biaxial moment, and bidirection shear force, you can use Design Plus and you can get the results very quickly. The another requirement when we are designing a base plate includes the requirement of the stiffness. Usually if the moment is huge and the moment is in one direction only, then we need to add some stiffness. In order to strengthen our connection without increasing the base plate thickness, we can add the stiffness here. So for example, if we see here, so here this is a stiffener. So there are 4 stiffeners which have been added in this base plate connection, and they will help us to strengthen the connection, and we don't need to increase the base plate thickness that much. So along with the rib plates, we can also use the wing plates to strengthen our connection. So here you can see that in case the strength of the section is quite low, we can use the wing plate stiffness in order to strengthen our section. So both the stiffeners, they have their own advantages when it comes to different situations. Midas Design Plus is capable of modeling and analyzing both of these stiffeners. So there is a very less possibility that you will not be able to simulate what you actually want. You can input the height of the stiffener, you can input the length of the stiffener. Based on that, the program will analyze and it will generate the drawing for you and it will design the base plate for you. Similarly, the base plate design module supports the welding check. Now there will be various instances when the section will be welded to the base plate, and even these rib plates, they will be welded to the base plate as well as to the section. So Midas Design Plus is capable of performing the welding check for all these connections, and you can specify the material for the welding and you can specify the various effective lengths in various directions, and based on your data the program will apply the welding check. We'll see the welding check in more details in the demonstration and the report that we will generate using Midas Design Plus. Now talking about the mode of input, since Design Plus is a 2D module, it cannot analyze the 3D structure by itself. So what we need to do is we need to import the design forces from various other programs. You can import the forces from programs including Midas Gen, Midas Engine, and you can even import the forces from various other programs like StatPro, eTabs, Tekla Structure Designer, and any of the programs. So let's see what are the various modes of input available. The first and the foremost input mode is the graphic interface. So in this interface, you can use the various drop-down boxes. So you can use you can specify the material for the plate, for the anchor bolt, for the concrete, and then you can manually specify the force for the axial, the moment in the X and Y direction, similarly the shear in X and Y direction. And then you can specify the section shape by this drop down menu. You can first select the section shape and then you can specify the database section. And if you don't want database section, then you can just check off this option and then you will be able to specify the dimensions of the section manually here. So this is the graphic based input where you can input the parameters one by one. The other input which is available for the Design Plus includes a table based input. This is a more general input and it allows you to specify your data more quickly. So here you can see that in a Excel like table, you can specify the various parameters. So for example, if you want to specify the force, you can simply specify the force in the form of an Excel table. Now the advantage of using this Excel format is that you can just copy paste the data from various other programs into this table, and the program will perform the design and checking for you, and it will eventually generate the drawings for you. So in this way, you don't need to manually specify the data one by one using the graphic input. You can just create an Excel sheet in the desired format, and then you can copy paste the Excel sheet to this member list tab of Design Plus. So here, if you choose this member list tab, you will get this Excel format. And once you specify the data, you copy paste the data in this Excel format, the program will perform the usual analysis and design for you, and it will generate the drawings as well. Now talking about the modes of operation, that what are the various modes of operation available in Design Plus. There are two modes of operation in Design Plus. The first is the design mode, the second is the checking mode. In the design mode, what you need to do is that you just need to input the design forces and the section shapes. Based on this data, the program will decide the number of bolts and the arrangement of the stiffness, and even the thickness of the base plate will be decided by Design Plus. So once you input the design forces and the section shape, the program will optimize your base plate, and it will give you the outputs of the required number of bolts, stiffness, and the thickness of the base plate. So this can be very easily used by QPs. And for the checkers, there is an option available called checking. In the checking, you need to input all the data. You need to input the design forces, section shapes, bolt and stiffener configuration, and even the base plate thickness. Once you're using this checking mode, the program will provide you the design ratio based on the input data. The program will not iterate any of the configurations. It will simply calculate the design ratio based on the configuration specified by you. So both these modes are available in Design Plus. And regarding the check on the anchor bolts for the prime force, we'll see some details in the demonstration part itself. So now let's see that what types of inputs can be generated using the Design Plus. So the first and the most widely used output available for the design is the PDF report. In Midas Design Plus, you can generate the PDF report for the various modules. So for the base plate, you can generate a PDF report, and the PDF report will contain a section diagram, and it will contain the various result diagrams, and it will also contain the input diagram and all the equations which have been used from the Eurocode. They will be listed with the section specification. So this PDF report can be generated, and it can be generated for all the base plates at once. And similarly, you have the report in the Word format. So similar to the PDF format, the Word report will contain a section diagram, and it will contain the various inputs based on you are performing the design or the checking. And then it will specify the design forces and everything, and then it will contain all the equations as per the Eurocode which have been used for the design. Then the last output will be in the form of a DWG or DXF drawing. So once you're using the Design Plus, you don't need to spend a lot of effort on performing the base plate design and then drafting it manually. In the Design Plus, once you have specified the base plate data, the program will perform the design as well as drafting for you. You can save these drawings as DWG DXF. You can even customize these drawings before the auto generation, and then you can directly integrate with the rest of the structural drawings. So now let's see how we can use this in Design Plus. So here I'll start the program Design Plus. And we'll see here step-by-step procedure in order to perform the base plate design. So the first step is that I will change the code to the Eurocode, and I'll change the material to the Singapore NX, and I'll change the steel code as well to Eurocode. So here you will see that these are the various modules available for the Eurocodes. And once you want to perform the base plate design, you can go to the steel tab, and in the steel option, you can check off this option and you can click on the base plate and just start the base plate. So now by default, you will be directed to the project mode of the Design Plus. There are two other modes available. We'll see in the demonstration that what are the various modes and in what situations are they useful. So now I'll change the units to the SI units. So let's see how we can perform the base plate design as per the Eurocode. So the first thing is that we can select the material for the base plate. You can specify various materials as per the Eurocode, and similarly you can specify the material for the anchor bolts as well. Then if the base plate is placed on a pedestal, then we need to specify the material for the pedestal, and then we can specify the forces. So let's specify the axial force, and then let's specify the moment. So if you want to specify this data in terms of the load combination, you can even specify the data in the terms of load combination, and the program will perform the design for all the load combinations. And then we can choose the section shape. So for example, for the section shape here, you can see that you can choose the section shape from the database. And if you want to specify the section shape manually, you can just input the section shape and the program will generate the figure based on your input data. So this is quite simple and straightforward, and you can customize the base plate as required by you. Along with box, you can use the pipe section and you can use the angle section and you can use the channel section. So this is the similar what we have seen in the presentation. So once you specify your data regarding the section size, you can specify the welding data. So you can specify the effective lengths to be used in the X and Y direction. And then if you come to the section 2, you can choose the section of the base plate. So let's say if you want to design a circular base plate or you want to design a rectangular base plate, both the options are available. You can mix and match the section and the base plate itself. Then if the base plate is placed on a pedestal and you want to design the pedestal as well, so you can specify the shape. So you can specify the circular or the rectangular pedestal, and then you can specify the dimensions of the pedestal and you can specify the grouting length. And then you can choose the types of the anchor bolt, and then you can choose the diameter of the anchor bolts. So based on your data, the anchor bolts will be generated, and you can specify the lengths of the anchor bolts to be used. And if you want to change their position in X and Y direction, you can even change that. So all this input can be changed. And in the section 3, you can specify if you need the stiffness. So let's say if you want to specify the stiffness, you can specify the stiffness using this format. And in case you want to specify the wing plate, you can even specify the wing plate for the use in the base plate. So this is the procedure for performing the base plate design. And once you're done with that, you can just click on checking. So both the options are available. You can go for checking and you can even go for the design. So here you can see that once you perform the checking, the program is giving you the design ratios in the form of a table. And you want to see the drawings, you can just go to the drawing tab and you can click on create. So the program will generate the drawing for you once you have specified the data. And if you want to do this in the spreadsheet format, you can just move to this member list tab, and there you can specify the forces, the section, and everything in a table based format, and you can perform the complete design and drafting using this table format itself. So once you're done with that, you can click on the report and you can click on the detail. The program will generate a Word report for the base plate design. You can save this Word report, you can print this Word report, and you can use it in any manner. So now we'll switch to the simple mode and we'll see that what option is available in the simple mode. So now if I take you through this Word report for the design, you will see that the first data is about the input. So what is the code used and what is the material used for the base plate and what are the various sections used for the base plate. And there will be a figure of the base plate, then about the design forces, then the bearing stress on the base plate, and then the tensile forces, and then the base plates checking. So the program will contain the entire information about the shear force and the anchor bolts, and even the welding check will be there. So using the design plates, the program will perform the checking on the anchor bolts as well. So all the equations as per the Eurocode, they will be checked, and it will also be checked for the combined shear and torsion forces. So the program will list all the equations used for that purpose, and you can quickly refer for the check. You can use this report. Now let's switch to the simple mode and let's see that what are the various options and what are the various advantages of using a simple mode. So here in simple mode, we can click on checking, and for the report, we can quickly click on the report and choose the option of generating a detail, a summary, or an input list. Here you can maximize or magnify the size of the text. So here you will see that this is the PDF report and the program is giving you the entire information about the tension stress of the anchor bolt and the tension forces and the tensile strength check. All the equations as per code, they are listed. And then the FEM analysis of the base plate. The various diagrams are included for the shear force. And the program is checking the entire moment strength based on the Eurocode. And similarly for the anchor bolts, the checks will be applied, and for the welding as well. So this is how we can use it. Now let's try to perform the design for a circular base plate which is supporting a pipe section. So for that we can move to the project mode again, or we can specify it in the simple mode itself. So now here I'll specify a pipe section with some particular data, and which is not placed on pedestal, but the section for the base plate, it will be a circular section. And here we'll use some stiffness. So we have specified the stiffness. The thickness of the stiffness can also be specified. And once we do that, we can even specify the bolts if we want to. So here you can change the number of bolts if you want. So here you will see that we can specify the number of bolts that we want, and if you want to increase the number of bolts, so you can just specify here and then you can click on checking and the program will perform the check for you. So for the circular base plates, I'll save this, and for the circular base plates we can perform the design. So here you can see that we have used the various stiffness and the bolt data is specified, and this is all included in the report. And similarly the shear force diagram and the moment diagram are included. And even for the rib plate, you will see that the moment diagrams are included. In this particular base plate, we have 6 rib plates. So all the 6 moment diagrams and the shear force diagram, they are included in the list. And all the checks, they are listed in this particular report. So we can print this report in this format. And if you want to generate the drawing, you can simply go to the drawing tab and you can click on create and it will generate the drawing for you. Let me retry it. So first I should change it to steel base plate and then click on create. So the program will generate this drawing for you, which you can save as dwgdxf. So once you generate the drawing, so all the information will be listed here, including the thickness. And once you generate this drawing, you can save this drawing by clicking on save as, and you can choose a format to be saved. You can use either DWG, DXF, and even other options like JPG, BMP, PNG. They are available for the drawing saving. So this was about the Eurocode baseplate design in Midas Design Plus. If you have any questions, please write down your questions in the questions window. I'll take up the questions after a while. Thank you for joining today's webinar. And if you have any questions, you can write to us at info@midasit.com. Thank you.